Okay, good morning everyone. So this time I will discuss to you about the mathematics in 11 or general mathematics 11. So probably that tackles about introduction on piecewise function and the operations on functions. So there are two topics that I am going to discuss this morning. So that is on the piecewise function and operations on functions. So actually in the previous year from grade 7 to grade 10, they had been encountering functions but only for linear function and quadratic function. But at this time, we have new type of function which is the piecewise function that includes its application. Then the operations and functions actually, they already encountered this one because this is just a matter of executing what the addition, subtraction, multiplication, and division. Okay, so let us have first. Piecewise function is a function in which more than one formula is used to define the output over the different pieces of the domain. Okay, so very clear. It means that this type of function, it is being subdivided into functions. So daghang siyang sulod actually. Like for example, we have here a sample problem for its application. A school's fair committee wants to sell T-shirts for their school fair. They found a supplier that sells T-shirts at a price of 175 pesos a piece, but can charge 15,000 pesos for a bulk order of 100 shirts and 125 pesos for each excess T-shirts after that. Use a piecewise function to represent the cost in terms of the number of t-shirts purchased. So we are asked to identify the piecewise function that model this type of problem. Wherein, what are the things that we need to remember, particularly in converting this word problem into function, particularly piecewise functions, that we have to identify some quantity that we need to consider. First, we have here a book order of 100 shirts. So it means that when somebody will order, no, at exactly when n is equal to 100, so it will charge 15,000, no? Charge of 15,000. But for those who wanted to purchase between 0 to 99, so the price would be 195 pesos. So that's it. Then for every exist over 100, so they will charge each by 125 pesos. So we have here okay, the solution for this problem. We have n is referring to the number of t-shirts purchased. So we have here in the first part we have 175n, or the first function 175n, if n is greater than 0 but less than 99. So that is actually being described in the first statement, that they found a supplier that sells t-shirts at a price of 175 a piece. Okay. Then secondly, we have here 15,000 if n is equal to 100. So this one, or this function, referring to the statement that but can charge 15,000 for a bulk order of 100 shirts. So that's it. Then thirdly, we have here 15,000 plus 125 times the quantity of n minus 100. If n is greater than 100, so this function is actually being described at and 125 pesos for each exists t-shirts after that, no? So that is how we are going to model this given problem using a piecewise function. Okay, let us proceed now to example, still on piecewise function, but we are on evaluating on it now. So actually in evaluating the piecewise function, let us have to consider also those variables that is being restricted. Like for example, we are given f of x is equal to the first function, we have 5 minus 2x if x is less than 0. So we have to bear always in our mind that we can have, or we can evaluate this first function 5 minus 2x when x is less than 0. So meaning only those values which are negative. Second, x minus 1 if x is greater than or equal to 1. So we can evaluate the second function x minus 1 if x is greater than or equal to 1. So it can be 1 going to positive infinity, because talking about inequality, there are a lot of solution. Then thirdly, we have 2x minus 5 if x is equal to 0. So there is only one variable, only one value rather, to which this function is being evaluated, which is x is equal to 0. Next, we have here the solution. Okay, we are asked to find, okay, for letter A, f of negative 2, and letter B, f of positive 2, and letter C is f of 0. Okay, we have solution. For letter A, f of negative 2 become positive 9 because we know that that is negative. No? We use negative 2, or we want to evaluate the function using x is equal to negative 2. So that is belong to the first function, which is 5 minus 2x, because as we observed that the variable has been restricted that x must be less than 0. We know that negative 2 is less than 0. So letter B, we have here f of 2 which is equal to 1. So that is equivalent to 1. So we use the second function, which is x minus 1 if x is greater than or equal to 1, as being restricted that the value of x must be greater than or equal to 1. Okay, so 2 is greater than 1. So meaning that is acceptable. For letter C, we have f of 0 is equal to negative 5. We know that in here we are going to evaluate the function when x is 0. So if you're going to observe which of them that we are going to evaluate is the third one, which is 2x minus 5, as evident that x is equal to 0. So meaning that is only evaluated when x is equal to 0. Okay, we have here the next one. Okay, let us proceed on operations on functions. So there are four fundamental operations in on functions. No? First one, we have addition and subtraction. So actually, this addition and subtraction can be what have the same concept, particularly in simplifying, because talking about fraction, of course, we will have to get their LCD. No? Then simplifying, as we add or subtract from the numerator part, the resulting difference or sum will be the numerator, but while the common LCD will be their denominator. No? Then for multiplication of fractions, of course, we don't need to identify the LCD. But what we are going to do is, if there are terms that can be simplified or cancelled out from numerator and denominator, then we will have to use execute it. No? Then, of course, if there are no terms that can be simplified into or simply that can be simplified into smaller terms, then therefore we'll have to multiply both numerator and denominator, so that we could easily get, or we could get their product, no, between the two fractions. Okay, so let us have here some example. Okay, let us have first, no, wala na natin apil ang division. So we have division to divide two fractions or rational expressions. Multiply the dividend with the reciprocal of the divisor. So of course, this is common to us because when we were in what elementary, we still using, or we were using the concept, no, when we are going to divide two fractions, we will have to get the reciprocal of the divisor, and we will have to follow the concept of multiplication of two fractions. Okay, so for answering, like for example, if we want to identify the sum, the difference, the product, and the quotient of the functions. Okay, so we will have to execute these four steps. No, first, there's sum denoted by f plus g of x is the function denoted by, okay, there's sum itself. No, f of x plus g of x. Second, their difference denoted by f minus g of x is the function denoted by, of course, each difference, now f of x minus g of x. Number 3, their product denoted by f of z of x is the function denoted by the product between f of x and z of x. Fourth, their quotient denoted by f of z of x is the function denoted by, we have f of x over g of x, provided that g of x must not be equal to 0, or else this given fraction become undefined, okay, because g of x is equal to 0, but because g of x should not be equal to 0, so therefore the function will not become undefined. Okay, we have here an illustrative example. Express the function below as the sum, difference, quotient, or product. No? Letter A, we have here f of x is equal to x squared minus x minus 2 as the first function. Then second, we have g of x is equal to x minus 2. But because we want to identify the four fundamental operation, or execute the four fundamental operation, so therefore let us have to, or let us start with getting the sum. No? So for letter A, we have sum for f of x plus g of x. So that is equivalent to the quantity of x squared minus x minus 2 plus the quantity of x minus 2. So actually, in adding polynomial, what we are going to do is we will have to add those similar terms. No? As we observed that x squared has no x squared in the other function, so just copy that one, x squared. Then we have negative x, and the other function has x. So we have negative x plus x become 0 because they are unlike sign number. Then, in terms of their constant, we have negative 2 plus negative 2 become negative 4. Okay, for the difference, we have f of x minus g of x. So the same process, but we just, but this time we will use the difference, no, or minus sign. No? First, we have x squared minus x minus 2 minus the quantity of x minus 2. We write down the quantity because we still have, no, the close and open parentheses, because we still have to distribute the negative sign to each term of x minus 2. So become, we will write first the first function. We have x squared minus x minus 2. Then we have negative times x, negative x. Then become, we also have negative times negative 2 become positive 2. So if we're going to simplify, just copy x squared. Then we have negative x and negative x become negative 2x. Negative 2 plus positive 2 become 0. So finally, we have here the difference between f of x and g of x as equivalent to x squared minus 2x. Okay, so we will go directly to their product between f of x and g of x. So we will write first the first function, x squared minus x minus 2, multiplied by the second one, we have x minus 2. That is equivalent to x cubed minus x squared minus 2x minus, how we obtain that one? Because we have x squared minus x become x cubed, negative x times x become x squared, negative x squared, negative 2 times x, negative 2x. Then we have here the last term in the right hand side, we have negative 2 times x squared, negative 2x squared, negative 2 times negative x, positive 2x, negative 2 times negative 2 is positive 4. Then combining like terms, we write first the terms that has the highest exponent. So we have x cubed followed by squared term. So we have negative 3x squared because negative x squared plus negative 2x squared become negative 3x squared. Then for the x term, we have negative 2x and positive 2x become 0 because they are equal at the same time. They are unlike sign number. Then just copy the constant term, which is positive 4. So finally, the product between f of x and z of x, we have here x cubed minus 3x squared plus 4. Lastly, we have here the quotient between f of x and z of x. So we will have to rewrite in the numerator part, corresponds to f of x. We have x squared minus x minus 2. Then while the denominator, we have z of x as equivalent to x minus 2. As what we observe in the numerator part, that is actually factorable. So we can make use of two binomial factor. Same concept concept that you had been learned when you were in grade 10 and grade 9 because you had been encountering factoring using two binomial factor, especially those quadratic function. Okay, so when we factor, we will have to consider the first term, the last, we will have to factor the first term, the last term, but we need also to consider the middle term. So from that become the factor of the numerator of x squared minus x minus 2 become x minus 2 times the quantity of x plus 1. So if we're going to simplify this 2 binomial factor, it will go back to its original form, which is x squared minus x minus 2. While in the denominator part, we have x minus 2. Since there are common terms from numerator and denominator, then this is now the time that we can eliminate or we can cancel out those terms that are the same. So we have x minus 2 and x minus 2. So canceled out. So finally, our quotient for f of x and g of x, we have the remaining one, which is x plus 1. Okay, so thank you for watching. Then at the same time, that I think or I hope that that will help you, particularly in answering your activity, especially if you want to study or if you want to learn more about piecewise function as well as evaluating on it, and also for executing the four fundamental operations on functions.